Hello students, welcome to Educate. In the last class, we have mainly discussed about the introduction of the chemistry. In that one, we have discussed that actually the chemistry starts from where? That is law of conservation. That means law of chemical composition. So the law of chemical combination, sorry, law of chemical combination, from there the chemistry starts. And before that, like significant figures and unit and dimension, they are the basic concepts of physics and chemistry both. So in physics you will discuss in later in detail. In physics you will study about the units and their dimension, as well as the significant figures in detail. That's why I have left that topic. If you would, anyone would like to take guidelines from myself, from my, then may write in the comment box of the YouTube channel Educate. Definitely I shall make a video for that. Okay, so from here, that is, firstly we start from mole concept and molar mass. Molar mass, what is that here? Molar mass is the mass of 1 mole of substance. That is called molar mass. Molar mass means mass of 1 mole of substance. Like that, for any atoms, for any atoms, for any atoms, molar mass will be actually the atomic mass. Molar mass will be atomic mass, and that will be mass of 1 mole of 1 mole atoms. Mass of 1 mole atoms. As for example, the cost of bananas usually sold in terms of number, and that is per dozen. So when you will ask to any shopkeeper what's the cost, so some shopkeeper will tell that his cost is rupees 70 or rupees 80 or rupees 60 per dozen. And in some shops, when you will go, and he will tell that rupees 50 or rupees 45 per kg. So selling of the bananas will be in terms of two quantities. That is, one is the mass, and another one is in terms of number. So just like that, 1 dozen means 12. So same, 1 dozen means 12. Like 1 dozen banana. 1 dozen banana means 12 banana. In the same way, if there will be 5 dozen lemon, if anyone will ask 5 dozen lemon, so that means that will be equal to 5 into 12 lemon. Same here, 1 mole atom means 6.023 into 10 power 23 atoms. In the same way, if 5 mole molecule, so that will be equal to 5 into, that will be equal to 5 into 6.023 into 10 power 23 molecules. Okay, in the same way, if there will be 3 mole iron, so that will be equal to 3 into 6.023 into 10 power 23 ions. That is about the ions. Okay, that is the meaning of mole. Okay, now molar mass, that means molar mass of any atom, if you will have to find out, so that will be equal to their atomic mass, and that means mass of 1 mole atoms. Okay, you know, the suppose here you know already the atomic mass of sodium is 23. The atomic mass of sodium is 23. That means mass of 1 mole sodium atom. Atomic mass of sodium, you know, 23. So when the number of moles of sodium will be 1, that is 6.023 into 10 power 23 atoms, then their mass will be 23 gram. So that is here. 1 mole sodium, then that means mass of 1 mole sodium atom or 6.023 into 10 power 23 atoms is 23 gram. That is about the, if you will have to find out molar mass of any atom, so molar mass of any atom will be their atomic mass, and that means the mass of 1 mole of that atoms, that will be their atomic mass. So same here, one more example I am taking, that is, suppose atomic mass of chlorine is 35.5. Chlorine, atomic mass of chlorine is 35.5 U. 35.5 U. Same, atomic mass of sodium is 23 U. So that means when the number of chlorine atom will be 1 mole, that means number of chlorine will be 6.023 into 10 to the 23 atoms. When the number of chlorine atoms will be 1 mole or number of chlorine atoms will be 6.023 into 10 power 23, then their mass will be 35.5 gram. So atomic mass of chlorine is 35.5 U. That means the mass of 1 mole chlorine atom, that is 6.023 into 10 power 23 atoms of chlorine will be 35.5 gram. Clear, guys? I think no problem here. Same, just watch out. Usually in a single instant, a number of persons drink half liter water generally. So what happened? How much water molecules he consume, how much number of water molecules he drinks in a single instant, and let's see here. Let's see, molar mass of water. Molar mass of water. And molar mass means molecular mass. Molar mass of water, that is molecular mass, is 80 U. That means mass of 1 mole water molecule, that is 6.023 into 10 power 23 water molecules will be 18 gram. Okay, any problem, guys? Here you know already the molar mass of water is 18 U. That means when the number of molecules of water will be 1 U or 6.023 into 10 power 23 molecule, then their mass will be 18 gram. Now I am calculating mass number of water molecule in half liter of water. So let's see 18 gram. When weight is 18 gram, then water molecule will be 1 mole, that is 6.023 into 10 raised power 23. When weight is 18 gram, number of water molecules is how much? 6.023 into 10 power 23. So when weight is 1 gram, so when weight will be 1 gram, so here if more be the number of water molecules, if more be the number of water molecules, then more be the weight. As more be the number of bananas, more be their weight. So here more be the so that means here mass and number is directly proportional here. So when weight is 1 gram, number of water molecule will be how much? Water molecules will be how much? So 6.023 into 10 power 23, that upon 18. And there is half liter water means 500 gram water. Half liter water means, because density of water is density of 1 kg per liter. 1 kg per liter or 1 gram per milliliter, because here 1 kg 1000 gram, 1 milliliter 100,000 milliliter, so 1000 cancel out. So that is same here in terms of kg per liter and in terms of gram per milliliter, the density will be same. So density of water is 1 kg per liter or 1 gram per milliliter. So here 500 milliliter water means 500 gram water. So when weight will be 500 gram, then what happened? Number of water molecules will be, that will be 6.023 into 10 power 23 upon 18 into here, that is 500, that much gram it is. So multiply that, you will get the result. In the examination, what to do? That is in the case of MCQ questions, how to solve fastly. Let's see, 6.023, that can be considered as 6. So 6 3 ja 18. Now 3 1 ja 3, carry 1, 3 1 ja 3, carry 3 6 ja 18, 3 7 ja 3 1 ja 3, carry 2, 3 6 ja 18, and you carry 2, again 3 6 ja 18, or approximately 167 or 166.66. So that will be into 10 power 23. So that will be number of, so that is here. So you can write also that therefore the number of water molecules in 500 milliliter water, that will be equal to how much? Here 66.6 into 10 power 23, represented the scientific notation. So the point will go this side, so that will be 6.6 into 10 power 24, that much. So in a single instant, as normal persons consume that much number of water molecules. Okay, that is 6.6 into 10 to the power 24. Okay guys, that is. Now let's see percentage composition. Percentage composition. What's the meaning of percentage? You already know. Percentage, what's the meaning? So percentage means out of 100, how much is that? Let's see about the CO2. In case of carbon dioxide, what will be the percentage composition of their constituent elements? In CO2, there will be only two elements, that is carbon and oxygen. Let's see here, percentage CO2 here. So molecular weight will be how much? 12 plus 2 into 16, that will be 44. So molecular weight of CO2 is 44 U, or that can be also written as 44 gram per milliliter. So molecular weight of CO2, you can write that molecular weight or molar mass. Molar mass of CO2 is 44 U or 44 gram per milliliter. That is here. So that is what's the meaning here. CO2 44 there is, and carbon is how much? So 44 gram of carbon contain how much? 12 gram carbon. So 1 grams, 44 gram of CO2 contain 12 gram carbon. So 1 gram of CO2, that means more be its weight. If the weight of CO2 will be less, then weight of carbon will be also less. And if the weight of CO2 will be more, then weight of carbon will be also more. So here it is directly proportional. So directly proportional. So that's we will write. So 1 gram of CO2 contain how much? 12 upon 44, that much gram carbon. And here it is asking percentage composition, means when you will have to find out the percentage composition of carbon and oxygen, percentage composition in CO2. So that means if the total weight of CO2 will be 100 gram, then what will be the weight of their constituent elements? That will be called their percentage composition. Okay, percentage composition means here, if the weight of that molecule will be 100 gram, then what will be the weight of their constituent elements? That will be called their percentage composition. So here in CO2 there is two elements, that is carbon and oxygen. So you will have to find out the weight of carbon when the total weight of CO2 will be 100 gram. In the same way, you will have to calculate the weight of oxygen when the weight of CO2 will be 100 gram. So let's see here, 44 gram of CO2 contain 12 gram carbon. So 1 gram CO2 will contain 12 upon 44 gram carbon. So 100 gram CO2 will contain how much? 12 upon 44 into 100. That much gram. So guys, I don't think so anyone feel difficulty here. Very simple it is. Simple mathematics here. So now calculate this one. 4 3 is 12, 11 here. So 300 upon 11, that much gram. Now divide here. 11 2 ja 22, carry 8, and 11 7 ja 77, carry 3, 11 2 ja 22, and here 11 2 ja 22. So again that came 11 2 ja 22. So 8. So that means 22. 27.22. That much gram. So that is here. So therefore that means percentage composition in CO2 is 27.22% carbon, and about the oxygen we will have to calculate. So let's see here again. So in CO2, oxygen is how much? Weight of, when molecular weight of CO2 is 44 U. So, and weight of oxygen is 32 here. So that means 44 gram of CO2 contain how much? 32 gram oxygen. So 1 gram CO2 will contain how much? 32 upon 44, that much gram oxygen. And it is, you will have to calculate about when percentage composition means when the total weight of CO2 will be 100, then what will be? So 100 gram of CO2 will contain how much? 32 upon 44 into 100, that much gram oxygen. Calculate here. 4 8 is 32 and here 11, that is 800 upon 11. 11 7 is 77, 11 2 is 11 2 is 11, 11 7 is 77, carry 3, 11 2 is 22, 22 carry how much? 8, 11 7 is so 72.7, and whatever you would like to tell, that is here, that much 7, approximately that much percentage composition. So that means here percentage composition in CO2 is 27.22% carbon and 72.7% oxygen. Here the meaning of this one here is that the percentage of composition of CO2 is 27.22% carbon and 72.7% oxygen. So that you may write in your notebook, you should write that the percentage composition of CO2 is 27.22% carbon and 72.7% oxygen. Okay. On the basis of this one percentage composition, okay, let's see one example also of percentage composition. Let's see percentage composition in glucose. We will calculate the percentage composition in glucose. Okay, so given percentage composition in glucose. So glucose here is molecular weight of molecular formula of glucose is C6H12O6. Molecular formula that much. So let's see firstly, watch out their mass. 6 carbon here, so that will be 6 into 12 plus hydrogen is 12 into atomic weight of carbon hydrogen is 1. So that's why 12 into 1. Here why atom is 6? Because number of carbon atom is 6. In one glucose molecule, the number of carbon atom will be 6. And atomic weight of carbon is 12. So that's why it will be 6 into 12. And for the hydrogen, that there is 12 hydrogen. So that's why 12 into atomic weight of hydrogen is 1. So that is this one. Plus, here there is 6 oxygen. So 6 into oxygen atomic weight is 16. So that's 16. So that will be 72 plus 12 plus 96. 180. So at molecular weight of glucose is 180, or the molar mass of glucose is 180 U. That is molar mass or here in this is a molecule, that's why we tell molecular mass or molecular mass. Now first find out percentage composition. So carbon how much? So 180 gram of glucose contain how much? How much carbon? This 72 gram, 26 into 12, 72. So contain 72 gram carbon. So 100 gram of glucose will contain how much? 72 upon 180 into 100. 9 8 ja 72, 9 2 ja 80. Now 4 2 ja 8, 4 5 ja 20, 5 2 ja 10, 0, that is 40. So here 40% that is glucose, carbon 40%. Now let's about hydrogen. So that was about percentage composition. So in glucose, carbon is how much? Carbon here is 40%. And hydrogen how much? So 180 gram of glucose contain how much? Here 12 gram. Because 12 hydrogen and atomic mass of hydrogen is 1. So 12 into 1, that means 12. So 180 gram of 180 gram of CO glucose. 180 gram of glucose contain how much? 12 gram hydrogen. So there is how much you have to calculate in 100 gram. So 100 gram of glucose contain how much? 12 upon 180 into 100. That much hydrogen. Calculate that 0 0 cancel out. 6 2 is 12, 6 3 is 18. Now 20 upon 3. 6.66. That much. So percentage composition here, hydrogen is how much? 6.66%. 6.6% or 6.66%. Now let's see about the oxygen. So same 180 gram of glucose contain how much oxygen? Oxygen here is 6 oxygen and atomic weight of oxygen is 16. So 6 into 16, that is 96. So contain 96 gram oxygen. So 100 gram will contain how much? 96 upon 180 into 100. So that means 5.3. That means here that is nearly about 50.3. 53. That is 53. 53.3, whatever you want to write. That is 53 point something. So that is 53 point something. How much? 3 take. That is 53.3. So option is here 53.3. How to check that is correct or not? You add all of them. If that comes 100, that means 100, and there be since in the calculation everywhere everyone and not only we, everyone will take approximate value. So that will come nearly about 100. Then that is correct. The way in which you are doing, that is correct. So let's see here, that is how much in this case? 639. That means here something wrong. Here this one, 96 upon 180, 96 upon 180 into 100. How much is come? So calculate guys, calculate this one, 96 upon 180 into 100. So 53.33. 53.33. Hydrogen, how much was there? Okay, 72 upon 180. %. 6.66. So add this one here, 53. This one, 99.9. So that means calculation is done correctly. Okay, guys, this one. But these formulas, if percentage composition is given, or if percentage composition will be given, then you can also calculate the molecular mass of that molecule. If percentage composition of a molecule will be provided, then you can also calculate the molecular formula of that compound. And here frequently asked question is particularly in NEET examination and in IIT main examination. Questions frequently asked about to find out the molecular formula of a compound. Let's see here from the questions directly we will do, not from here. Maybe you get confused from here. So here my motive was only to teach you what's the meaning of percentage composition. The question asked from here from the topic of percentage composition is the percentage composition will be given, and in the questions question will ask about write the formula of the compound. So let's see here. Now let's see how to do this question. That was how we have calculated. Now empirical formula and molecular formula, about that we will discuss. Okay, firstly let's see about the empirical formula and molecular formula. What's the meaning of empirical formula? Empirical formula means the formula which represent the ratio of various elements present in a molecule. The ratio of various elements present in a molecule, that is called their empirical formula. And molecular formula is the number of various elements present in a molecule. The number of atoms of various elements present in a molecule, that is called molecular formula. Empirical formula is the ratio of the number of atoms of various elements in a molecule of the compound, and molecular formula is the total number. Molecular formula is the number of atoms of various elements present in a molecule of the compound, that is molecular formula. Okay, so let's see. Firstly write that what is the meaning of empirical formula. So you may write that empirical formula. Empirical formula is the formula. Empirical formula is the formula which represent the empirical formula is the formula which represent the ratio of the atoms of different elements present in a molecule of the compound. And molecular formula is, that is about the molecular formula, the formula which represent the number of atoms of, the formula which represent the number of atoms of different elements in a molecule of the compound, that is called molecular formula. Now let's see, watch out this question. Read the question. In this question, there is given percentage composition. So percentage composition of hydrogen is 4.07%, carbon 24.27%, chlorine 76.65%, and its molar mass is given. Molar mass of the compound is given, and it is asking what are its empirical and molecular formulas. What's its empirical formulas and molecular formulas? That is asking. That means in empirical formulas, it is asking that the different elements are present in the molecule in which ratio. The number of atoms of different elements are present in a molecule of that compound in which ratio. First question is that, and second question is asking that in a molecule of that compound, what will be the number of atoms of different elements. So let's see here. So percentage composition is given. The percentage composition is this much. That means if the total weight of that compound will be 100 gram, if the total weight of that compound will be 100 gram, then weight of hydrogen will be 4.07 gram, the weight of carbon will be 24.7 gram, the weight of chlorine will be 71.65 gram. That means here question is here it is asking, that means percentage composition is given. That means if the total weight of the compound will be 100 gram, then weight of hydrogen will be 4.07 gram, the weight of carbon will be 24.7 gram, and the weight of chlorine will be 71.65 gram. Okay, so if there will be 4.07 gram hydrogen, then what will be the number of atoms of hydrogen? Firstly, that we will have to calculate. So firstly, let's see. Firstly, we will calculate the number of atoms of different elements. The number of atoms of different elements. So let's see here. So number of atoms or number of moles of atoms, you will tell that. So number of moles of hydrogen, that will be how much? That is 4.07 upon 1, that is 4.07. Same number of moles of, there is carbon. The number of moles of carbon will be how much? 24.27 upon 12. That is how much? That's to calculate 24 point. So divide that 24.27 divide by. So what is here? 24.27. That is in gram, and it is gram per mole. It is gram. It will be in gram per mole. So divide 24.27 by 12. Calculate that firstly. That will comes 2.0225. 2.022. So that means 2.022. That is. Now number of moles of chlorine, find out. So number of moles of chlorine. So that will be equal to here how much? It is given 71.65 gram. So 71.65 gram, 71.65 gram, that upon 35.5 gram per mole. So divide 71.65 divide 71.65 by divide 71.65 by 35.5. That is coming 2.01. So that is 2.01. That equal to 2.01, that much mole. That is here number of moles of hydrogen 4.07, carbon 2.022, chlorine 2.01. And how to find out their ratio? So to get ratio, which number is the smallest? By that number, we divide all the number. To get the ratio, which one is the smallest number? By that number, we divide all the numbers. So same here, ratio of carbon, hydrogen and chlorine. That is how much? So 4.07 is to 2.022 is to 2.01. So here that is merely about 2 here. So by the 2, divide all of them. So what will be here? So nearly ratio will be here, this one here, 2:1:1. So 2:1:1. Ratio is that 2:1:1. So that means hydrogen 2, carbon 2 and chlorine also 2. So empirical formula will be that will be CH2Cl2. Okay, that is this one empirical formula is CH2Cl2. Guys, first of all, you understood, then copy it. Then after I shall proceed on how to find out the molecular formula. I hope you have copied. Now I am proceeding. So empirical formula is CH2Cl2. So I will have to wipe this one. Now let's see. Empirical formula is that much. So what will be the empirical formula mass? So empirical formula mass will be how much? 12 into 2 into 1. Sorry. 12 not into plus here. So that will equal to 12 plus 2 into 1 plus 2 into 35.5. That is 12 plus 2 plus 71. 85. Sorry. Empirical formula was the ratio of, in that one, ratio of carbon, hydrogen and chlorine was 1:2:1. So empirical formula that will equal to CH2Cl. So what is here? So empirical formula was that will be equal to how much? 12 plus 2 plus 35.5. 2 to 4 and 5, 9. and 314. 49.5. That is this one. So you watch out here. The molecular formula is the molecular mass is approximately same. The molecular mass is approximately twice of the empirical formula mass. So that means empirical formula mass is that much. So molecular formula mass when divided by empirical formula mass, so that will equal to here. Empirical molecular mass was how much given? So I will have to proceed. So for guys, written, I hope you have written. Now let's see. Molecular mass was given here, how much? 98.96. So molecular, so that will be equal to here 98.96, that upon 49 point, what was there, how much we have calculated the empirical formula mass. Watch out. So that was 49.49. So when you divide them, 49.46 you have calculated. So that will be nearly 2. So empirical formula was CH2Cl. So empirical formula was that much. That's why molecular formula will also multiply by there. So here by 2, so C2, here also 2, so H4, here by 2, so Cl2. So molecular formula will be CH2Cl2. So that means percentage composition of the molecule was given. Based on that, we had to calculate the molecular formula of the compound. So how to solve? Like this one. Okay guys, it's all for this class, but this topic has not been finished. Based on this topic, we will discuss one or two questions of this, one of the exercise questions. So that will be in the next class. It's all for this class. Thank you, Team Educate.